Okay, in this video, we're going to learn about aldehydes and ketones. So in the previous video, we learned about the functional group of hydroxyl. That was an OH. In this case, we're going to learn about a new functional group, and that's going to be the carbonyl group. So that's a C that's double bonded with an oxygen. Okay, now the difference between aldehydes and ketones is the location of this carbonyl group. So this is a carbonyl group. Okay, so when this carbonyl group is at the end, so that means if it's at the end of a long chain, that means that on one side we can have, carbons and a bunch of different carbons there, and at least one hydrogen has to be attached to it, right? So if it's found at the end, that means that this carbon is going to be attached to this one hydrogen here. Let's just complete this molecule, CH2, CH3. So our focus here is on this section. When the carbonyl group is at the end, this is what we call an aldehyde. When the carbonyl group, which is just the C double bonded to the O, is found in the middle of a compound, so that means that it's connected to other carbons. Let's say this is this 3-carbon molecule, so CH3 on this side, CH3 on this side. This carbonyl is found in the middle, so it's not attached or bonded to this hydrogen like we see in the aldehyde, but rather it's in the middle of this molecule. So that means that this is a ketone. So other than that, the differences between the aldehydes and ketones are not that much, right? So this is a ketone and this is an aldehyde. Aldehydes end with Al, while ketones end with ONE. Okay, so molecules that end in Al, you know that there's an aldehyde involved, and molecules that end in ONE, you know that there's a ketone involved. In terms of aldehydes, you don't have to number or you don't have to specify location ever. So don't specify location. And if you think about why that might be, because aldehydes are found at the end of a molecule, you always want to give it the priority. So that carbon is always going to be carbon number 1. So because it's found at the very, very end. So keeping that in mind, you don't ever have to specify the location of an aldehyde because it is going to be at carbon number 1. Whereas the ketone, it could be in the middle of a molecule, right? So if you've got an 8-chain carbon, it could be on carbon number 2 or carbon number 3 or carbon number 4. So depending on which carbon that is at, you have to specify the location. So have to specify location. There is an exception to this, and that exception is this particular molecule that I've drawn here. So this is the shortest possible ketone that we can have, right? So if it's any shorter than this, it's going to be an aldehyde. If you've got 2 carbons and a carbonyl group on it, it's gonna have to be attached to one of those hydrogens. So you know that this is going to be if it was a 2-carbon chain, it would be an aldehyde. So this is the shortest possible ketone that we would have, and that is propanone. So for propanone, you don't have to specify the location because we know that a ketone has to be in the center, or the carbonyl group has to be in the middle of that molecule. There's only one possibility for that ketone location to be at. It's going to be at carbon number 2. So because of that, you don't have to specify. But usually in other scenarios, you would. Let's take a look at this example here. So firstly, we want to identify if this is going to be an aldehyde or a ketone. So if you take a look at this here, we've got this double bond between this carbon and this oxygen. We see that this carbon is not attached to any more carbons, which means that this is an aldehyde. So there's a hydrogen there. Okay, so having said that, we can just go ahead and do exactly what we've been doing, which is to number our longest continuous carbon chain. So because the aldehyde is here, I'm going to start here with carbon number 1, 2, 3, 4, 5, 6. Okay, so this is a 6-carbon chain, and there is an aldehyde at the end of it. So this is going to be, so I start with my alkane naming, and I'm going to get rid of the E. So it's going to be, the E is gone from there, and it has the ending of AL. So hex and al. Okay, so that's my parent sort of chain here. I've accounted for the aldehyde. I do have here a side group, and this side group has 1, 2 carbons. And this 2 carbon side group is on carbon number 4. So this is going to be 4-ethyl. So 4-ethyl hexanal would be this molecule. Okay, our next example here, again, we see a carbonyl group. We see that this carbon is attached to this oxygen with a double bond. But we notice that this is then again attached to another carbon. So this has got to be a ketone. So I'm going to give this the lowest possible number I can, which it's not 1, it's going to be 2. So 1, 2, 3, 4, 5, 6, 7. Okay, so this is a 7-carbon chain with a ketone at location number 2. So when I'm naming this, I would first start off by having my alkane name. I'm going to get rid of the E. And of course, when you're writing it, you don't have to first write the E and erase it. I'm just sort of making a point here. I'm just making this a little bit more obvious to show you the steps, right? So heptan to one, right? We know that ketones end with ONE. And then I will have to specify any side groups that I see. So I see that on carbon number 4, I've got 2 different methyls here. So I have 4,4-dimethyl heptan 2-one. Okay, so that's how you'd name this particular ketone. I'm just going to go back to my main slide here, and I'm going to give you this particular compound before we leave. So I want you to draw butanone. So butanone is also a ketone, and you'll notice that I have not specified the number. I forgot to add earlier, but propanone and butanone are exceptions to this, having to specify the location of our ketone. And I want you to think about why that would be. So why would you not specify the location of the ketone at butanone? Okay, so that was aldehydes and ketones. When we get to class tomorrow, we will practice more naming for these as well as more drawing as well. Okay.